Inshallah, this is the next part of special functions, beta gamma functions. Before going into the next proof, which is very important, let we have some basics here. See here, whenever we have to change the Cartesian xy coordinates in terms of polar coordinates r comma theta, we use this formulas. X, the value of x will be r cos theta, the value of r will be y will be r sin theta, and x square plus r square y square will be the value is r square. Also, where we have to change dx dy in terms of this means we have to use dx dy equals to r into dr deta. One more thing you see here, when we have x equals to 0 to infinity, y equals to 0 to infinity, it means it is the first quadrant. I will explain you. This is x 0 and here infinity, so x is 0 to infinity, 0 to infinity. Here y 0 to infinity, so this means it is first quadrant. So in terms, if we have to change this Cartesian xy in terms of r theta, then we say theta equals to 0 to pi by 2, because theta is in first quadrant, the angle will be 0 to 90 degrees, 0 to 90 degrees, therefore this is 0 to pi by 2. Whereas r is the distance of the point from, suppose, from this fixed point 0, so r can be anywhere from here to infinity, therefore r can be used as 0 to infinity, 0 to infinity. So when we have to change x and y in terms of r theta, 0 to infinity, 0 to infinity, we change like this: 0 to pi by 2 for angle 90 degrees first quadrant, and r value will be from 0 to infinity. R value will be from 0 to infinity. Revise this, inshallah. We have to do one proof from all. Now see here, let me start. We have to prove this one: beta of m comma n equals to gamma of m into gamma of n by gamma of m plus n. There are many methods, but I am using here the transformation from xy to r theta. What is the formula of gamma of n? Let me start here. Gamma of n is integration 0 to infinity x power n minus 1 into e power minus x dx. But it's easier if we use, in place of x, let me start, let me put t. In place of x, let me put here. Now what is the substitution is? Must remember this step. You have to put t equals to x square. This is the method actually. You have to put t equals to x square. Now you differentiate this one. This t will be dt, differentiation. X square is 2x dx. So we got the value of dt equals to 2x dx. You see there is no change in the limits. If you put x equals to 0, t will be 0, infinity. Now this gamma of n will become integration of 0 to infinity t. In place of t, we have to write x square power n minus 1 into e power minus. In place of t, let me write x square. Dt is 2x dx. Now see here, let me take out 2 outside because it is constant. And these bases are same. Let me add this. Okay, see here, 2 into integration 0 to infinity. This will be x power 2 into n, 2n minus 2 into 1, 2. This power is 1, so we can write plus 1. X a power m into a power n is a power m plus 1. These two are having bases same, so we can add the powers. Its power is 2n minus 2 plus 1 into e power minus x square dx. Now this is gamma of n equals to 2 into integration 0 to infinity x power 2n minus 1 into e power minus x square dx. Similarly, let me write gamma of m in terms of y. So we can write 2 into 0 to infinity y power 2n minus 2m. Here is m, we are having 2m minus 1 into e power minus y square dy. Now in formula we have to prove gamma of m into gamma of n. So let me multiply this one. Therefore, gamma of m into gamma of n. We have to multiply this 2. So if you multiply 2 into 2 will be 4 into integration 0 to infinity x power 2n minus 1 e power minus x square dx into integration 0 to infinity y power 2m minus 1 into e power minus y square dy. Now see here, 4 into, we can write this 2 as this double integration. We can change this into double integration. We can write like this: 0 to infinity, this is x, again 0 to infinity, this is y. This 2 I am writing first: x power 2n minus 1 plus y, sorry, into, what is here, y power 2m minus 1. I'm writing first x and y, then this into e power. What we are having, you see these two are bases same. Let me add the powers. This will be minus x square minus y square dx dy dx dy. These two integrations we joined here, double integration x y e power minus x square minus y. Let me take minus common from here. Let me take minus common from here. Now we have to change here into the polar coordinates. We take minus, if you take minus common, just you take minus common here, it will become plus. See, so let me now change into polar coordinates. Change to polar coordinates. Now just we have seen how is the method to change into polar coordinates. In place of x we can write r cos theta. In place of y we can write r sin theta. In place of dx dy we can write r dr d theta. One more thing is there, x square plus y square equals to r square. Now what about the limits? This is x, this is y. Just now explained, this is first quadrant. So for first quadrant, theta will be from 0 to pi by 2 and r will be from 0 to infinity. So let me change this one. So what will become if we change this here? I'm changing this whole, equals to 4 into integration theta equals to 0 to pi by 2 into r equals to 0 to infinity. Now x values are cos theta power 2n minus 1 into r sin theta power 2m minus 1 into e power minus x square plus y square is r square. So dx dy will be r dr d theta. So let me continue from the starting of the board. Now see here, the next step is very important. See here, I'm changing this into two integrations. Let me separate the theta. This 4 I'm writing 2 into another 2, let me take inside this one. I'm writing like this, 2 into integration 0 to pi by 2. 2 into integration 0 to pi by 2. I'm writing this one. Sine power 2m minus 1 theta cos power 2n minus 1 theta d theta into, you see once more, I'm writing 4 as 2 into 0 to pi by 2. I'm separating theta here. Sine power 2m minus 1 theta cos power 2. I separated theta. Now what is left here? One more 2 is here. I'm using here 2 into integration 0 to infinity. Now you write r values, r power. Here r power we are having 2n minus 1 into r power 2m minus 1 into r into e power minus r squared dr dt. Sorry, here it is dr. So you see here, we separated the theta and we separated r here. The bases are same here. This power is 1. Let me add the powers. Now watch here carefully. We already proved this one. We are having this proof now, beta of m comma n equals to 2 into integration 0 to pi by 2 sine power 2m minus 1 theta cos power 2n minus 1 theta d theta. So let me change this one, equals to 2 in, sorry, this will become beta of m comma n. Now into 2 into what is here, 0 to infinity. If we add powers, this power is 1, this will become 2n minus 1 plus 2m minus 1 plus 1 plus 1 minus 1 we can cancel. R to the power of, you take 2 common from this, 2 into m plus n minus 1 into e power minus r squared dr into e power minus r squared dr. What we are having here? We are having here gamma of m, gamma of n. Now last time, watch carefully. In the starting, we note one thing there. Gamma of n is, we are have already disproved in the starting step. You see here, it is already written like this. Gamma of n equals to integration 0 to infinity r power 2n minus 1 into e power minus r squared dr. This we already, just now we substitute this one. Gamma of n will be 0 to infinity r power 2n minus 1 into e power minus r squared dr. In the same way, you see, what is the difference between this? This and this are same. Just in place of n, we are having m plus n. That means this value is gamma of m plus n. You see already we have just in few steps before we wrote this one, gamma of n is this. So what is the difference between this? Only in place of n we are having m plus n. So this will become this here also we are having 2. This all will become gamma of m plus n. Therefore gamma of m into gamma of n equals to beta of m comma n into this value is nothing but gamma of m plus n. Now the last step you bring this here, therefore what is left here? Beta of m comma n equals to gamma of m into gamma of n by gamma of m plus n. So this proof is very important. We practice this one. See here in the starting step, this is written in terms of x actually. This is x power 2n minus 1 e power minus x. This is dx. So what is the difference? Same you see here. This is gamma of n. We have written in the starting step. It's 2 into 0 to infinity x power 2n minus 1 into e power minus x squared dx. You see, if you compare this to this is same. Just in place of n, you are having m plus n. In place of r, you are having x. That means this is same as gamma of m plus n. So we wrote this gamma of m plus n. This is you see in the starting step we have done. Better you note this as equation 1 there. Better you note add this as equation 1 there. So you are using equation 1 here. Okay, now let me do the next question. See here we have to prove the next one. This is also important proof. Gamma of n into gamma of 1 minus n equals to pi by sin n. To prove this formula we have to use this identity. So you must by heart this one. Remember this identity. Integration 0 to infinity x power 2m by 1 plus x power 2n dx. Its value will be pi by 2n cosec 2m plus 1 by 2n pi. So you must by heart this one, pi by 2n cosec 2m plus 1 by 2n into pi. This logic, this method, this formula we have to use to prove this. So let me start. See here, solution how we start. We know there is a formula of beta of m comma in terms of 0 to infinity x power n minus 1 by 1 plus x power m plus n dx. You also know that if you want to change into gamma, we can write like that, like this, gamma of m into gamma of n by gamma of m plus. So let me use this too. Now what is the method is, watch carefully. We have to suppose this m plus n as 1. Let see here, m plus n equals to 1. Now you find the value of here, you find the value of m. So m will be 1 minus n. So this if you keep 1 here, gamma of 1 will be 1. Gamma of m will be 1 minus n. We have to prove this one 1 minus n. We have to bring this 1 minus n. Therefore, in place of m, we can write 1 minus n. In place of m plus 1, 1. Here also 1. So let me continue using this 2. Okay. Therefore, this will become integration 0 to infinity x power n minus 1 divided by 1 plus x dx equals to, I'm writing this gamma of n into gamma of m is 1 minus n and divided by gamma of m plus n is 1. But gamma of 1 is 1, gamma of 1 is 1, so we can leave this one. We note this as equation 1, let me use this later, okay? Now we have to use the identity, we know. Just now we have discussed the formula. What is the formula? Integration 0 to infinity x power 2n divided by 1 plus x power 2n dx equals to pi by 2n cosec 2m plus 1 by 2n into pi. So we use now how to change. Watch carefully. The first step, how to change. Here see we are having just 1 plus x. We don't have the power of x here, so we have to take out the power of x here. For that, let me put x power 2n equals to some other, let me suppose this y. Let x power 2n equals to y. So this will become 1 plus y, like this, 1 plus x, 1 plus y. Bring this 2n on the other side. This will be x equals to y power 1 by 2n. Now differentiation of x is dx. D by dx of x power n is n into x power n minus 1 dy. So this is dx and this is x and this is x power 2n. Now let me change this one. What will become integration? There is no change in the limits. If we put x0, y will be 0, infinity, infinity. So limits will be 0 to infinity x power 2n. X value is y power 1 by 2n. Power 2m means here it will come 2m. So you come, this 2m will come here. So this x power 2m is y power 1 by 2n is x. Whole power 2m means 2m will come here, divided by 1 plus x power 2n we have taken y. And what is dx here? The dx changes to 1 by 2n into y power 1 by 2n minus 1. Okay, so dy equals, you write this as it is. Let me change one more thing. Let me change 2m plus 1 by 2n equals to, suppose I am changing as k. So this will become pi by 2n cosec k pi. Cosec k. You see here both sides we are having 2n 2n. Let me cancel this one. This 2n 2n will get cancelled. Now these two are bases same. Let me add the powers. What are the powers here? Here the power is 2m by 2n plus here the power is 1 by 2n minus 1. If you take LCM, this 2m, you write like this, m 2m plus 1 minus 1. For this 2, you take LCM 2m, this will be 2m plus 1 minus 1. So we take the LCM here, bases are same. So see here, integration 0 to infinity, y to the power of, you see here, y to the power of, what is here, 2m plus 1 by 2n minus 1 divided by 1 plus y dy equals to pi by, bring this cosec in the denominator, it would be sine k pi. Now see here, we suppose this as k. See here, 2m plus 1 by 2 is k. So we write k here. Therefore, integration 0 to infinity y power k minus 1 divided by 1 plus y dy equals to pi by sine k pi. Now let me change the variables. We can change the variables. In place of k, let you keep n. In place of k, let you keep n. And in place of y, let me change x. We can change the variables. We can change the variables. So this will become 0 to infinity x power n minus 1 by 1 plus x dy. So this will become pi by sine n. Let me note this too. Now the formula is finished. You see here, in the here what we have noted, integration 0 to infinity x power n minus 1 by 1 plus x is gamma of n into gamma of 1 minus n. The same here we got this as integration 0 to infinity x power, this we got. Therefore from 1 into, therefore from 1 into, what we can say is gamma of n into gamma of 1 minus n equals to pi by sine n. So this is the proof we have to do. This is the proof we have to do. So inshallah, let me continue in the next class, because these are two tough questions. You practice yourself. You practice these questions 2-3 times by yourself. See every step how we are changing the, because sometimes the proofs will be difficult. We have to remember the steps, and especially where we are changing, how we are starting the steps, what are the big things which are using in between the steps. So you practice this one, and by heart this one, practice this one, inshallah. Let me continue in the next class. Let me do few more questions of this chapter in the last class, inshallah, next part, inshallah.